So amplitude is 6. What is the range? Range is from the lowest, which is -3, going to the highest, that is 9. What is the y-intercept? It's crossing y-intercept at -3. So when x is 0, y is -3. And what is the phase shift? You don't use much of phase shift here, although if you're looking for the vocabularies, when you find, in this case, you're moving everything pi/4 to the left. So if you solve inside the parentheses, then you would get 2x is equal to -pi/2. X is -pi/4. So phase shift is -pi/4 or pi/4 to the left. Okay. So the next few are graphing. Okay, let's do some of the graphing. Number 5. Y equal to 2. Y equal to sine 2x plus pi. So what you can do here is put 2x plus pi, again between the period of 0 to 2 pi. Then you solve for x. So 2x between -pi to pi, you divide everything by 2. So x is between -pi/2 to pi/2. Amplitude is 1. So once you go graphing this one, you start from the -pi/2 all the way to pi/2. Half of -pi/2 to pi/2 is 0. Half of that is pi/4. Half of that is -pi/4. And then you go from -1 to 1. Amplitude is 1, so you just go with the behavior of sine. Again, starting from 0, going up, down. In the third increment, you go down to -1, go up to 0. That's the graph. And that's over 1 period. They ask for over 2 period. If you need more period, you can add more points until you get to where you want. If you look at here, every increment has a length of pi/4. So you can keep adding pi/4s to get to the next period. And then if you think about here, period is 2 pi/2, so it's pi. So one way to think about it is if you are adding pi to pi/2, because that's going to be one whole period here. So adding pi, which is 1 period, to the last point, which is pi/2, giving denominator of 1, it's 3 pi/2. So right here is 3 pi/2. Then you can find half of these by adding them together and dividing by 2, and so on and so forth. Or again, you could have add pi/4s because that's the length of each increment. So this is gonna be 3 pi over 4 if you're adding pi over 4 to pi over 2. Adding another pi over 4, it's gonna be 4 pi over 4, which is pi. Adding another one, it's gonna be 5 pi over 4. And then 6 pi over 4, which is 3 pi over 2. So continuing the pattern, you go up. In the next increment, you're on the highest. Then you go back to 0, going to the lowest, back to 0. So that's over 2 period. And again, the one that I'm going to make darker is the second period. These are periodic functions. They can go forever. Okay. Next question. Let's do number 6. Y is equal to negative cosine 2x. Again, you can think of 2x being between 0 to 2 pi, knowing that that's the period for regular cosine, but now you're dividing by 2. And in reality, that is the period of cosine 2x, because if you were using the formula of 2 pi over b, you would have get pi as well. So you can do it either way. I would say this one works for everything, so use that. So if you think of graphing here, you go 0 to pi. Half of that is pi over 2. Half of that is pi over 4. Half of that is 3 pi over 4. Let me change the color here. The behavior is cosine. So you start from the highest to lowest. Just keep in mind that you will have a negative or a flip at the end. If you are going with the regular behavior of cosine, I'm going to use broken lines. So that would have been the regular behavior. Now you are talking about negative cosine x. So you go from the bottom, top, back to the bottom. So that's the graph of negative cosine 2x. Okay. Let's do the next one. Number 7. It says y equal to 2 plus cosine x. This is just regular cosine function being moved up. So that means that the period is 2 pi. Oh, again, remember, even for last question, if you want to go over 2 period, you would continue. So let me continue if in case you didn't know how to do it. If you want to go another period for over 2 period, then you want to find all these increments here. Find the half of that. Pi and 2 pi is 3 pi. 3 pi over 2 is half of that. Half of pi and 3 pi over 2. You add them and you divide it by 2. So you're going to get 5 pi over 4. And this is 7 pi over 4. So if you were continuing for another period, then this would have been the next period. So you go from here to the highest to 0 to the lowest. Okay, now going back to the question we were at. So here we go. This is for one period is 2 pi. I'm going to draw that and I'm going to continue to the next period. Always drawing in one period is easier. So cosine, negative 1 to 1. So half of that is pi, half of that is pi over 2, 3 pi over 2. So it's gonna be broken dots. If you were going for another period of, this is just cosine x for now, then this would have been 4 pi, half of 2 pi, and 4 pi is 6 pi divided by 2 is 3 pi. Half of that is 2 pi, 3 pi is 5 pi divided by 2. Half of 3 pi, 4 pi is 7 pi over 2. So if you were continuing the pattern, this would have been the pattern. So you go down, you go up, and you go here. So that's for 2 period, 1, and then 2 period of cosine. Now the function says 2 plus 2, so then you're shifting it up 2 points. Every points will go up 2. So take every point and go up 2. 1, 2, 1, 2. 1, 2, 1, 2, and 1, 2 back to 3. So you're basically shifting it. Okay, and that's 2 period, 1, and then 2. Okay, that's the graph for number 7. Number 8. Pause the video at any point that you think you need extra time. Y is equal to -1 plus 2 sine x plus pi. As what we did in the past. So you're going to put inside parentheses between 0 to 2 pi. That's the period of sine. Once you start graphing, for 1 period, you can go between -pi all the way to pi. Period of this one is 2 pi. As you see, nothing, 1 is multiplied by x. Half of that -pi over 2, half of that pi over 2. Then you have -1 to +1. So once you want to graph it for 1 period, remember that the amplitude is 2. So I'm going to go to 2. And then I'm going to go to 2. So once I start graphing, it's sine. So I start from 0. Going to the highest at 2 because that's the amplitude, coming down to 0, going down to -2, and then coming back to pi. So that's just the piece of 2 sine x plus pi. Now it says -1, so that means every point you have, you take it and you bring it down 1. Down 1. Down 1, down 1, so it's going to be -3, and down 1. So once you connect them, you get the graph of the function of what you have here as a whole. On the test, if I ask you to give me few of the final points coordinates, then you're going to tell me what is x, like x is pi in this case and -1 is the y, or in this case x is -pi over 2 and y is 1. So I could ask a couple of points on the graph, -pi, -1.